Hello everyone, welcome to lecture number 18 of the course. In this lecture, we're going to do a quick data types review before we continue with our intermediate projects. Because these intermediate and advanced projects will become increasingly intensive on data types. Although Scratch doesn't actually put much emphasis on it within their own platform, like Scratch doesn't call strings of text strings, they would just call it text, or they don't call um, one or zero values. They don't call them Booleans, or they call true or false values Booleans. I mean, sometimes they use the term Boolean, but it's not like inherently called that. So although it's not really required to know, it can help really accelerate your knowledge of programming in Scratch and really accelerate your progress. And so, also, if you choose to continue your programming career after this course, then you're actually going to have a much more solid foundation than if you did not see how these data types played out in block-based programming, so you can better understand how to apply them to text-based programming, and it makes a huge difference. Trust me, I've many people that I've gone into text-based programming have said that not only one of the first things I've turned them off as a beginner is data types, because it's one of the first things you learn, and it's just good to have a solid understanding of it already, so you can start really getting into writing cool functions once you get into text-based programming, and kind of skimming over a lot of the beginning part, which you're not always going to want to do, but it just kind of depends. It depends on your skill level and experience. Um, but you can always work on that, which is really cool. So what I'm gonna do is I'm just gonna go new project in the top right of the My Stuff folder, and I just want to review over some of the data types we've gone over in this course, and I think it could help actually a lot with these next projects. So I'm gonna name this one Data Types Review. I don't know if I'm gonna keep this project, so I probably won't go ahead and put it in the studio, but we'll see. Um, the studio for the course. I suppose we don't. This cat's fine actually. We'll keep him. Um, what I want to do is first I want to just add a comment so I can type out some things for you guys, and that's how I'm gonna start it. So I want to just go over the names of the data types we've been working with, and also when we can use them. And once I get into this, you might be wondering, well, why haven't you done this earlier? Because we've been kind of embedding the explanation of these within lectures of the course, and this is really important information, so why not make a separate lecture? Well, the main reason why is because I don't want to overload you guys with something that's not even really fully integrated into Scratch itself anyways. Like, Scratch doesn't have although data types are a huge part of Scratch, Scratch doesn't focus on data types itself. In other words, although you need to understand data types to get better with Scratch, you need to understand the concept of them, not the terminology behind it. But I want you to understand both the terminology and the concept, which is why I'm going to reinforce the terminology so that the concept can make more sense as I'm explaining and walking through it whenever we're working on projects. So whenever I talk about a string, you'll know what I'm talking about rather than me just talking about a block of text and then it just somehow works and, that type of thing. But I'm just going to go ahead and name the data types we've been working with throughout the course. So strings, booleans, integers. Alright? And variables are not a data type. That is a common misconception, especially in text-based programming, but variables are not a data type. Now, variables can hold data, and in Scratch, the only data type they can hold is integers, but I'll get more to what categories certain things fall under to within the context of Scratch in this lecture, so don't worry about that. But I've gone over strings, booleans, and integers, and we talked a little bit about characters. So I do want to go ahead and talk about characters, but we haven't. It's not really a huge part of Scratch, even conceptually, not just in terms of terminology. It's good to know it before you jump into text-based programming, anyways. So I'll just go over all four of these, since these are kind of the four. Really, strings, booleans, integers are the three core data types. We'll also get into characters a little bit. I mean, there's others, and a lot of them depend on language, but in almost every single programming language, you'll find strings, booleans, and integers, or some kind of equivalent. But usually they're implicitly called that, except for bool is often short for boolean, so it'll oftentimes just be bool. So just another uh, quick little fun fact there. Now, just to clarify, what everything is here, right? So strings, what strings are basically is strings would be text. And it can be text containing anything, even numbers or symbols. So it could even be like an individual character. It doesn't have to be a string of characters. By the way, a character is just one piece of text, like whether it's a letter or a symbol or a number. In fact, why don't we go characters first, just to clarify real quickly. So characters would be like a or one or dollar sign. It can be, you know, a number, letter, symbol, something like that. It just needs to be completely by itself and isolated and only one. And the reason why I'm using single quotations is because oftentimes in text-based programming we use single quotes for characters and double quotes for strings. Now keep in mind, strings are oftentimes more than one character, but they can also be one. So you might be wondering, and you know, strings can also be any of the three mentioned below. You know, it can be a single letter, number, dollar sign. The difference is we can do as many as we want. Like let's say apple. You know, we could do 100, not just one, because that's three characters, and we wouldn't normally be able to do those characters. And even though it's not an integer, we can still do numbers, and of course we can do uh, values such as symbols as well. And we can combine all these. They don't have to all be separated. We can do letters, numbers, and symbols in the same string or things like that. Now, here's another interesting thing. So, as far as strings go, you might be wondering why we don't just use strings instead of characters exclusively, and why we should only use strings. And that answer really lies in text-based programming. And because this is a block-based programming course, I'm not really going to go over it, and that's also why, because it's mostly a factor in text-based programming, and it really has to do with like something called dictionaries, which is basically where in some languages it's called dictionaries, and that's basically where, you know, whenever you're converting, let's say you're converting, maybe translating something, like if you're converting accented characters to non-accented characters, if you're working with languages, maybe you're working with like hexadecimal or binary and converting it to ASCII. ASCII is basically another word for well, it's an acronym, but it's basically just plain text, as we would call it. So, like, pretty much anything that any keyboard can type, so like emojis, text, you know, symbols from like all sorts of languages, not just like English, which is the characters we're using this course. All of that would be ASCII. And that's ASCII. If you're interested in looking that up, that's kind of an interesting and almost very important term to know for programming as well. Of course, for block-based programming, it's not a huge deal to know what it is, but it's kind of good to know what it is in general. Um, anyways, that kind of strays from the point. And so, as you can guess, one reason why it's not a huge focus of Scratch, this whole characters thing, is because it's more of a text-based programming thing and so Scratch is almost always better to use strings because not only can you do what characters can do, you can also do more, right? And I'm gonna actually give some more examples of all these. So right now I'm just talking about what these can be and what they can't be. Um, so Booleans. Booleans are essentially true or false. Now, quite literally, um, it is just true or false. So whether it's like, and these are surprisingly useful. And I actually usually prefer to use this than passing an integer to a variable. However, in Scratch, that's usually what we must do, rather than go ahead and just do true or false. We can't really do that. We have to have a variable and then maybe set it to 1 and set it to 0. Usually 1 means true and usually 0 means false. Um, so, and it can also have these same equivalents of 0, 1, but not, like for example, in text-based programming, you could do bool sandwich equals true, and then semicolon, because oftentimes we end with a semicolon. But that's just an example. So now if it were a, I don't really want to get into too much text-based programming in this course, but that's just an example. So bool pretty much signifies data type, and usually we literally use the word true. So it quite literally is true or false. It's basically whether it's not, and so I actually to explain this better. So any of these angular values, if you've noticed, if you click on them, let me zoom out here. There it went. So if you click on these, you'll notice that it'll say false or true. That's because any of these angular values, as we've been calling them, also have a Boolean value that can be expressed by clicking on them. So for example, 0 is not greater than 50, so it's false. However, 51 is greater than 50, so it's true. And we can actually use these to act as Boolean variables. So for example, whenever we do something like if mouse down, or if touching mouse pointer, like right now it's false, but and this is referring to the cat because that's the sprite we have selected. But if it were touching mouse pointer, if I were to click it somehow simultaneously, it would say true, just as an example. So that's a very cool thing there. And of course, what we do in general for Booleans, whenever we're not doing that, because we want to actually implement them into our code and not just use the concept of them through angular values. Usually, what we'll do is we'll just set something to 1, and we've already done this before, but we'll just set something to 1. And then if we want it to go off or false, we just set it to 0. So you'd use 0 as false, 1 is true. So if we're wanting to check whether something is running, whether something is on, whether the project's at a certain stage, we'll just kind of have a true or false representative. So the 1 being true and the 0 being false. And that's kind of the main concept there. This is really what you find yourself doing a lot in block-based programming in general, because there's not actual Booleans. You have to go ahead and do something like this, where you actually set a value in the form of an integer to a variable, which gets me to the next point here, which is integer, the next data type, if you will. And integers can be a value, a whole number value, and I shouldn't say whole number because whole number means I think it's every number from 0 to infinity. That is to countable infinity. I guess it is uncountable infinity. Actually, the difference between those is countable infinity would just be like 1, 2, 3, 4, 5, and uncountable infinity would be like not just 1, 2, 3, 4, 5, but all the numbers in between. So, for example, between 1 and 2, there's technically an infinite, but also kind of technically not an infinite amount of numbers. Like there's 1.1, and then there's 1.01 and 1.001, and so on. So all those numbers would be could also be an integer. So in the context of programming, in math, such as in classes such as algebra, you're actually not going to be integers mean something a little different. Like integers, like in programming, 1.5 could be an integer, but in math, it could not. Now in math, 1 and 2 could be integers, but not 1.5. So integers, programming, I'll just put one here, so integers. And I'm not just going to limit to algebra, since it could be other fields of math. And they have a universal meaning in math. So I'm just going to have a few more here that signify that it can also be negative numbers and 0. So it could be just like that. Now, in programming, it can be the same thing as math. So it can be any number between from negative infinity to positive infinity. So it could be negative 1006, it could be 504, it could be 42, it could be negative 0, or I guess negative 0 isn't a number, but it could be 0, right? You get the idea. And so it can be everything that math can be, an integer, but also a little bit more. It can be numbers in between. So really what these mean, if you're familiar with math terms, what this would be called is real numbers. An integer can be any real number whenever we're talking about programming. So it can be, and I mean, there's a couple languages where this is an exception, but in block-based programming, there's always you're always able to do decimals as well. So, all right. So we have all the numbers in between. So we could do. It doesn't have to be 1.5. It could be 1.2. It could even be up to, in Scratch's case, it could be up to 16 decimal places. I can't speak for all of block-based programming there, but in Scratch's case, and in most other cases, it's up to 16 decimal places, which basically means you could, I guess I can't do hyphens in between them, but you could do something like this, and it would be totally fine. That's still an acceptable integer. But as soon as you get 1, 2, 3, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, as soon as you had any numbers past this would be invalid. So this is exactly 16 numbers to the right of the decimal place, so it's all good to go. However, if I were to add another number making it 17, it would not work, or at least it would round it, thus making 326 go to 33, if that makes sense. And if you're not fully familiar with rounding, maybe you haven't gotten to that in math or not yet, this will be fine because you're probably not really going to be working with 16-digit decimal places much anyways in Scratch in general, but it's good to know that there is a limit to the numbers between numbers, if you will, whenever we're talking about programming integers, in the case of block-based programming, specifically Scratch. At least it'll round it at a certain point. Now here it is. So I just want to go over some very quick examples just to reinforce what we've gone over in this lecture. So as far as strings go, what's an example of a string? Well, this right here is a string, and I'm actually going to use this say function to demonstrate a lot of what I'm going to be doing. I got it nice and zoomed in here, and I'll just go ahead and say it right here. So I've got apple, banana. So this is apple space banana. And don't forget, strings can include spaces. Now, text-based programming, you can also include certain things that makes it break on a line, so like split between lines. You can also make it tab or indent. But in block-based programming, you can't do that, but you can add spaces. Like for example, in text-based programming, slash backslash n means new line. But since we're in block-based programming, we wouldn't do something like that. It's just simple text. It could be letters, numbers, or symbols, and spaces. In fact, I'm actually going to include that. Also, I should note that characters can be up to one space. Also, for any of these, it can also be a closed value, so it could just have absolutely no value to assign to it. So, for example, if I were to, because whenever you're doing a say function, you're passing a string data type as a parameter to say, meaning that it's actually outputting a string. It's not outputting an integer, it's not outputting a character, but it's outputting a string, so it could be any amount of text. But if we were to have nothing there, it's still a string. It's just, it's not really going to do anything because there is no string, but this is still an acceptable string. Nothing between them. Now, space between them is also okay. If I were to put a space here, we could do that. It'll even output it, and it can't output nothing, but it is still an acceptable data type, even if it doesn't look like it. And I accidentally deleted something. There we go. I just hit, on Windows, in my case, it's Control-Z to undo, by the way, in case you happen to run into an error while typing. Say, you can use a join operator between apple and banana. Basically, now we're passing an operator as a parameter to our say function. We're actually combining two strings. So all this operator is doing. And in text-based programming, this would not be an operator, but in block-based programming, it is still an operator. This right here. In text-based programming, really, I mean, there's a couple more, but ultimately, these are the four main operators in text-based programming: addition, subtraction, multiplication, and division. So really, this four symbols right here are kind of the core operators, text-based programming. But in block-based programming, there's more values that we refer to as operators. So just keep that in mind as well. I know I mentioned that earlier, but just something to keep in mind. Now, if we go ahead and pass apple space banana to our say function, we can actually say two separate strings. So if one of these were, let's say we had like answer or something, or we needed to have another string in there that was not exactly in the form of, or maybe we need to say username. We'll do that. Like hello username. So basically that'll say hello Udemy Scratch Course. We can't do that all in one line. So that's why we're splitting it so we can pass both strings to the same parameter, the same function. So we can say hello Udemy Scratch Course. Very cool. So that's strings for you, okay? And that characters, I can give like an example of kind of what they are. Like, if apple contains a, which it does, that's true. And it's just looking for a character here. The only thing is with Scratch you can actually do more, so we can go AP. Of course it contains APs, it's also true. If it contains apple, it's true because, well, that's literally the word, and I can't spell apple, can I? So yeah, it does contain apple, but if it contains apples, which, well, it doesn't, it'd be false. Of course, apples contains apple because that's simply a part of apples. So yes, and actually that's what we would call a substring, by the way. If this is true, the one on the left is a string and the one on the right is a substring because it is part of this string, and that's what we call in text-based programming. Again, I want to make this a really comfortable transition to text-based programming if you choose to continue your programming career. That's why I can't stop blabbering on about text-based programming, so please excuse it, especially if you don't intend to continue your programming career after this course, which, although I really highly recommend you do, I understand that there's time constraints and some people are simply not interested in certain subjects, and I thank you for going as far to take this course, so you still have an advantage in terms of your knowledge of programming in general. Here's Boolean. So we were to talk about how these angular values can, of course, represent true or false, but really, what we're doing is I mean, I already demonstrated this whole thing with this, but usually what we do for this, at least for this course, what I highly recommend you do, since this is the top method that all the really experienced block-based programmers are doing, even some of the beginners that have picked up on this, is that they're just setting a variable to 1 is setting a variable to 0, and this is just true and this is false. So now they have a Boolean equivalent with a variable as kind of the medium of transfer of data there. And of course, integers. Usually whenever we're using integers, we use them with operators. For example, 1 plus 1, and we're just adding two integers. I should also mention that integers don't have to be one digit. They can also have a decimal place up to 16 digits, but you can also have a very big number like this. And there's actually no limit as to how long this can be, unlike the amount of digits after the decimal place. So, if we did, let's say 12 plus 12, 12 plus 12, by the way, is 24. So if we click on this, it should be 24. Boom, there we go. So, that's basically adding integers together using an operator. But a very common way that we're going to use integers is even this right here is using integers to represent booleans, but if we could just not have to do that, we could just have it, set to 12, which is an integer. Variables, if you even try typing something on your keyboard, that is not an integer, it'll work. So let's say we want to set this A, and then we want to go join a variable with B. Shouldn't just say 4 B's, should say 4 A's. I know it's kind of a random example, but it's actually not going to work because this can only accept integer input. So even if and what's weird about this is sometimes you can type it in, sometimes it'll let you type it in, sometimes it'll actually stop you from typing in letters or symbols. Either way, it's actually letting me do it right now, but sometimes it doesn't. I think that's just a glitch with their API. However, basically, this is only for integers. It's integer only. Otherwise, it'll just default to 0 because it is an invalid value. And since it has to be an integer, it'll just set it 0 since it doesn't know what else to do. So you can't convert it to a string. Of course, in text-based programming, you can convert it to a string using a function, but that kind of function does not exist within Scratch to keep things simple. So you don't really need to do it anyways because there's other ways you can do things of a similar task by combining blocks together. We've already done that type of thing, like whenever we've gone ahead and done that interactive story, and we're combining strings and stuff. You don't really need variables for that have strings as their value rather than integers. But just know that variables are integers only, even if it sometimes lets you input other text. And I was a little bit confused to let me do that since usually it just doesn't let your keyboard input it. But either way, it'll just give you an invalid value of 0. So I hope this made a lot of sense. And I know that this one was kind of, information intensive. And so if you guys have any questions, of course, you can always message me on Udemy. And feel free to do that whenever, and I will get back to you as soon as I possibly can. So if you want to do that, it's always an option for you. Of course, the Scratch Wiki is also a great resource. They don't go too much into data types, so that's otherwise I would have referred you there as well. But I still recommend you go there for most of your needs. So I really thank you guys for tuning in, and I can't wait to get into some intermediate projects with you where we really start taking these concepts to the test. Alright, that said, I look forward to seeing you guys in the next